Okay, so because security is a massive, important thing when you're looking at connecting to a database, we're going to look at one of the most common vulnerabilities when working with PHP. I think this is probably the most common. And it's when you connect to a database and you start querying a database, when you start to introduce user input, you actually leave your database open to SQL injection. Now, we've already discussed what SQL injection is, so I'm not going to go into that. But what I am going to do is create an example of where we show an exploit actually happening. And this will sort of hopefully, help make sense of how queries can be modified based on user input. Because you might think, well, if I'm saying, log a user in where their username is something provided by a form and a password is something provided by a form, how can they enter values into the username and password field to modify the query? Surely my query is set in stone, and that's where a lot of people go wrong. So we're going to build a small, not application, but a small example of using a username and a password in a query. And we're going to go ahead and make it as if we're sort of logging in as such. We're going to give an output to say you are in if the user's entered the correct username and password. And we're going to echo sorry, wrong details if the user has entered a password that is incorrect and a username that is incorrect. So I've gone ahead and I've created a table here, which is a user's table. And it looks like this, but let's go ahead and just rebuild this, just so we can start from the beginning and understand where the data's lying and all that kind of stuff. So I'm going to go ahead and I'm going to drop the table users. So inside of my database, I'm going to show my tables, and I only have at the moment this articles table. So let's go ahead and build this users table. So I'm going to create a table called users, and the values I want are ID, username, and password. Okay, so our fake login is going to basically allow us to provide a username, a password, and then if they match what's in the database table, then we're in. So the ID is going to be an integer, it's going to be not null, and it's going to be the primary key, and it's also going to auto increment for every record we create. Now the username is going to be a varchar of 20, and the password is also going to be a varchar of 20. Now bear in mind we're storing unencrypted passwords here because this is an example. In reality you'd probably have more like a 60 character field for your password that would store a hash, maybe using the PHP password API, but we're just doing this as an example. So let's go ahead and describe the table that we've just created. And that shows us the ID, integer 11, not null, primary key, auto increment, and the username and the password, both varchar 20. So let's go and insert into the users table, and let's insert a username and a password. So the values for this is going to be Alex and password. Let's go ahead and do this again, but create a new user this time, and we'll choose Billy, and let's just say cat as the password. Very secure passwords. Let's go ahead and select everything from the users table just so we can see this data. So we've got a user ID of 1 with a username of Alex and a password of password, user ID of 2, username of Billy, password of cat. So now what we're going to do is we're going to build a very simple but effective to demonstrate SQL injection, and also learn a few things along the way to actually check if a user has logged in successfully. So we're going to need a couple of things first of all, and that is the username and password variables. So username and password, and these are going to come from, we could just go ahead and enter data like this. I want these to come from a user supplied source, and we all know that the get superglobal contains what's been passed in as a query string. So in this case it will be get username, and for password it will be get password. So just to test that, let's go ahead and echo out username and a space and password. So let's go ahead and look at this. So let's go ahead and say username equals Alex and password equals password. And there we go. So we've got the two values here. We've got Alex and password. We know that we can now feed them in. We can get rid of this line. So let's go ahead and construct the query. And the way of thinking here is that when we perform a query with passing this username and password in, how do we know which user or if a user has been logged in successfully? We know if a user has been logged in successfully if they provide a username and a password that both match. So if a user provides a username of Alex and a password, that means they're logged in. Now that's assuming that the username is unique, but in this case we can just assume that because this is an example. Let's go ahead and build up the query then. So the query is going to select the count, and the reason it's going to select the count is if the count is 1 or positive, it shouldn't be 2 because we have unique records. If the count is 1, that means that the user has logged in successfully because they provided a username and password together that match that record. So we're going to return this as count. So count everything, or count, sorry, on all rows as count. We'll go ahead and just capitalize that. And we want obviously this to come from the new users table that we've created. And the where condition here is where the username equals something and the password equals something. Now we know that in this case we can just go ahead and leave these single quotes in, that's fine, that's what we would normally do within a query, but then we go ahead and provide the username, and inside the password we go ahead and provide the password. Sorry, no $sign there. So it should be there. So now our query will look like this if we just echo our query out. There we go. So we've got select count as count from username from users where username equals Alex and password equals password. Let's just go and paste this into the terminal. And then it goes count 1. So if, for example, Alex misspelled his password and put password 1, we would get 0. So this is how we determine if a user is logged in correctly. We can also go ahead and do this with the example of Billy. So the password would be cat and the username would be Billy. That count is 1. Again, if Billy thought his username was Billy1, that would return 0. So this is basically the authentication and how it works. And we're doing that through the query string. So it's user provided data. So let's go ahead and just do the usual. We'll go ahead and check if the result, or check the result. So we'll say db query SQL. So actually performing the query here. If the result, if something's wrong, so if there's an error, we'll just die there. So otherwise, what we want to do is we want to say if result fetch object count. Now remember we selected the count as count, so this is accessing our fetched object. Echo you are in. Otherwise echo incorrect details. So when I go ahead and refresh this, what do we think it's going to say? You are in. If we type a wrong password, so if I type password 1, incorrect details. If I type an incorrect username, we get incorrect details. So we know that this sort of authentication works. As a sort of warning, I'm sure no one's going to actually do this, but do not implement this as an actual authentication system in any way at all. It's not suitable. We're just using this to demonstrate our SQL injection. So the point of this video now, we've built this system. We think, you know, oh yeah, this is fine, it works. How on earth could someone try and get around this? Because we've looked at the queries and we've looked at the fact that they must have a username and must have a password that match, so there's no way we can get around it, right? Well, let's just take this query and we'll create a new file and we'll paste it in here. And let's just take a look. Let's pull this down from where username. So this is the query. Something can go in here, so we'll leave this as an empty string for now, and something can go in here. Now, how could we possibly provide a value, for example, a password value in here, for it to make it look like a new query? Well, we know that we use single quotes here to determine that this is a value, a string value, but we can also provide single quotes inside of user submitted value. So really, I could enter the password in my in the browser as a single quote, which is a URL encoded is %27. So I can include this single quote here. So in the query, it would look like that. That's what's happened now, is that's actually broken the query. So if, for example, we just hop over to our code here and say db error, it now says you have an error in your SQL syntax, check blah 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 near the single quote. So we've already generated an error through the data that we've actually provided. But that's not all. That's not going to allow a user to get access. What we're trying to do here is enter something in the password field or something in the username field to make it so we get this result. So let's go back to our example over here. What happens if I say single quote? So remember, this here is the value that we're providing, or single quote equals single quote. So this taken out down here is the value we provide. So if the username equals this that we've provided, and this slots in here, paste it in there, this now changes the entire structure of the query. So the query now reads, select the count, which will always be 0 or 1, from users where the username is I don't know, Alex, this could literally be anything, and the password equals nothing, or nothing equals nothing. Does nothing equal nothing? Does an empty string equal an empty string? Yes, it does. So what happens is this query will return 1 as its count. So if you don't believe me, then we'll go ahead and just paste this in to our terminal, paste it in, hit enter, and we get a count. Well, we get a count of 2 actually. The reason that we get a count of 2 is because nothing equals nothing for both records, and we're returning the count, remember. So what happens here is, well, we've got a couple of things that we do. We're gonna do this actually for real now. So we'll do this for real, and then we'll look at some other considerations we can use down here, and then why they might not work. So you might just think, oh, well, I could just stick a, I don't know, because it's a value of 2, we could just say, well, I want that to equal 1. That's going to solve the problem. Well, it won't, because a user could stick a limit of 1 on their query. We'll look at that in just a moment. Anyway, let's go ahead and provide this in the password thing here. So we're going to say where password equals single quote, or single quote equals single quote. Enter, you are in. So now, with providing a silly password like that, we've now performed an SQL injection. So we've injected arbitrary code into this query, and it's manipulated the query to get the result we want. So the poor user Alex now has, or any user in fact, has the ability for their account to be compromised just because this has been left open. Now, we're going to look at actually protecting against SQL injection in the next couple of videos, both with using escaping and also using prepared statements. But in this case, we can't do things like ints like we looked at earlier, which mean that it will cast this value to an integer when we were doing the limit in the video a couple of videos back. So you might be thinking, well, actually, I could do this. This count has to then equal 1, or cast this to an integer, so it does a typecast as well. So when we hit enter here, this now doesn't work. But if I type limit of 1 on here, it doesn't work in this case. But the point is that we actually need to fix this problem at the source of the problem, rather than, actually trying to do sort of clever things like this, or trying to do clever things like this. So we need to look in the next couple of videos at how we can prevent this kind of thing. This is just an example. It really doesn't matter what kind of system you're using. The techniques for protecting against SQL injection are the same, and they should be used wherever data that isn't your statically hard-coded data is defined. Even if you're taking data, for example, from an external JSON feed or an external XML feed, or even reading it from previous database values, always escape the data. Let's head on and look at how we can do this.